So today I want to show you how to fake collisions using the 2D grid movement system in my previous video. And when you're finished, it should look something like this, where you can't move on the block that's occupied. So I believe we left off last time with a basic 2D grid movement system that we set up. And what we're first going to do is we're going to go to the tile map blueprint, and we're going to set up a loop to basically we're going to add some random collisions in the map that will take the form of chests. First, we're going to fix something here that we didn't fix last time, which is the spaces that your character could spawn would be too big by one tile. Because we need to do minus 1 to the width of the map. So the first thing we're going to do is we're just going to go -1 on both of these. And we're going to connect that to tile X, and then we'll do the same thing. Subtract. And we'll do -1 again. And we'll put that in tile Y. We'll clean this up a little bit. We don't really need this right now, so we're going to just disconnect that. And so we'll clean this up real quick. This is adding into the top, this one's adding to the bottom, this right on top. And so what we're going to do first is we're going to create another filter. So we're going to do this basically, we're just going to duplicate this almost. So what we're going to do is create another for loop on completion. So we'll just go for loop. And so this is going to be the last index. And then we're going to duplicate this. And this will be the loop body. And we will connect this to the last index, and we'll double click here just to make a little node. And then so the loop body is going to be a branch. And we're going to use a weighted boolean to create the condition to where we can weight the collision just randomly, just so that we can make sure that our thing works. So random bool with weight. We're going to set this to 0.1, so 10% of the blocks that we have will be set to the chest and with collision. And we will, on true, we're going to set tile, paper tile map, and drag this over here. And the new value is going to be make tile. And if you can choose whatever tile you want to be in here. I'm going to go tile set. And then we'll add this as, I believe my chest is at 184 tile index. How you can find that is open your tile set and check the tile, and down the bottom left corner there will be a number. This one's tile number 184. So that's how I got to that number. And we're going to take the index here. We'll plug this in the X. We'll take the index here and plug it in the Y. And then we're also going to, and then after this, we will go into add to matrix or add to array. And we're going to go to our 2D character and we're going to create a new variable. It will be just an integer, and we'll make that integer an array over here. And we'll rename this, we'll call this tile full. And so we will add this to, we'll add another one here and we'll just call it tile full as well. Just so we don't have to cast every time that we want to set the tile until it's all done. Then we'll add it all to the characters array of tile full. So what we're gonna do next is we're going to get tile center position for tile map, and we're going to set these. So when you're setting the layers in the actual tile map blueprint itself, the layers are reversed from when you just edit the tile map asset. So I believe we're going to set it so the base layer will be 2, would be 2 in the tile set asset, but here it's just going to be like the top layer will be 2 instead of the bottom layer, I believe. We're going to click the box world space, and so we get the return value. We're going to find or we'll take step positions here. We'll get step positions and we'll find that in step positions, and then we'll add that to the tile full array. And what we want to do next is on completion of this loop, we want to cast the blueprint 2D character. And as the 2D character, we want to add to the step positions where our character could step. And then we want to get the tile full from the 2D character. So we'll go tile full. We're going to set that. That's going to be set as our tile full here. And then we'll just print the length just so that we can tell how many chests we're spawning or collisions just in general. So print string. And let's see if we compile this. Did not compile our 2D character, so we gotta go back and do that. Now that will work there. So that now we have our step positions. We found the step positions that are equal to the tile center position. We add those to our tile full as integers. So we know which tiles are full by integer, just so we can get rid of any small variances that will happen with this program. And then we cast the 2D player, we set the step positions and the tile full positions. And then we get the length of this array to tell us how many collisions there will be. So let's see what happens for now. Alright, so there are 0 collisions here. what we're going to have to do here is we're going to have to open up our tile map. What we forgot to do is make tile map editable. I believe is the first thing. That's one thing that we have to do. Got that. The target needs to be, I don't know why it's doing this. Paper tile map. I'll save. Alright, so now we have chest in our map. What we're going to do next is we're going to create a new layer in our tile set. We'll add another layer. So this will be the layer that we will want to set our tiles to. We'll call it 1, and we'll check to see if that's right. And if it is, we'll leave it. So we'll compile. Alright, so now the chests are on top of our base layer. There are no collisions yet, but we have those stored and we just need to communicate those to the player to fake the collision. First thing we're going to do is we're going to do the rotation of this. We want to rotate around the z-axis 180. See what happens now. Maybe. Strange. Be 0 or 180, I believe, but bug there. So if this is 0, then it could be 180. I know we already tried that, but it's a little bit better. We got that bug again where our character is offset, but that should be fixed when we finish this. Okay, so now we have everything set up in the right direction. Next thing we want to do is go to our 2D character and we're going to fix these things. But first we're going to add a function. So we're going to fix these to move to certain integers in our step positions over actually teleporting to the position itself. So first we want to go to, we're going to add a variable, we're going to just call it CAD move. It's going to be a boolean. Single. And we will add a function. This is just going to be called move. And this function is going to create a branch. And we're going to have the inputs of the tile index. Be the integer. We're going to have, we're just going to call it new x and new y. The vectors. And actually, let's change these to floats since we don't need the full vector for the x and the y. And we're going to take the tile index. We're going to go is valid index just to check. Let's delete this. We'll take the create one more. We're going to get the step positions player and go as valid index. All right, take the index, see if it's part of the matrix just to make sure. We might remove this later if it causes some problems. And then we're going to go to true, make another branch. And then we'll check the distance. I think we can make this 2D. So we'll go distance 2D. I swear I saw it. Distance 2D. We can get rid of this actually. We'll break this split struct pin. So put this into basically what we're doing here is we want to check distance between the player and their new position to check if we're on the edge of the map. So let's try this one more time. Distance 2D. This is the new and we're gonna change this for now. We'll draw this new Y or player Y. We're just gonna check the distance between the player and the new Y. So we're gonna get the player Y, which is gonna be V1. And then we're going to go split struct spin again, and this will be the V2Y. We're just going to check the distance between this to see if it's greater than our step size, which is going to be 16, but we'll do 17 because this program does have variance, like I said before. So we'll go less equal to, we'll do 17. We might take this out just briefly so we can debug the rest of it and we'll come back to it. So we'll check this. So we check to make sure that the index is within the step positions of the player, which would be the new index, and then we're also going to take this, and we're going to find in full locations. So we'll go tile full, we'll get tile full, find and tile full. And then we're going to check to see if this index is within the tile full index. And to do that, we check to see if it's equal to -1. However, over here, the index the item was found at, or -1 if not found. So if we see if it's equal to -1. If it's not found, and that's true, so we're going to go to another branch. So if this is true, which means it's not found, then we want to set can move to false. And if step size is not less than 17, we will also set this to false. And then we have one more condition. If it's not a valid index, we'll also set this to false. And then We check this, and if this is false, we do find it in tile full. I might have this backwards, but we're just gonna go with it for now. We're just gonna duplicate this. We'll set can move to true, and then we'll just return. Actually, go to the move, then output. And we don't need an output, so we'll just return the return node. Don't need an output, delete those. So we're just going to set this boolean and check this boolean. And so we check this. This is true. Go through, we check if this is true. Check if this is true. I might have to reverse this, but this should work for now, I believe. So we're going to use this to determine every time we check our player location to see if they can move or can't move. So first what we're going to do is we can get rid of this, and we're going to keep the teleport just so that's our main method of movement in this system. So what we're going to do is we're going to set array location. So we actually need to create a array location. So just choose an integer. And we're going to set this to, we'll just set this to like 20. It's just going to pick a random location, and this spot might be occupied, but that should be okay. As long as there's an available block next to it, we can just move off this location. We can get the step positions player. And we can get from this context sensitive. And we should be alright just getting a copy. It doesn't really matter here. So we get the location in here, and then we're going to split the struct pin. And we'll plug that into the X and Y location. That should be alright for here. Let's compile and save that. See what happens. Alright, we're bugged a little bit. Go back. So now we just teleports us to whatever location 40 is, which is at the bottom. What we're going to do is disconnect. We'll just disconnect all these for right now. Actually, we'll just go ahead with this. Just delete it all. And we're just going to create one thing, and we can kind of copy and paste it. So we're going to get the array location that we're at. I'm going to set this new movement system up. We're going to get step positions player. We're going to get and the array location is going to be that. Basically what we want to do next is we want to grab our move, and with the step positions player here, we're going to, once we get the location, so we're going to get the array location, we're going to split the struct bin. This is going to be our current Y. And then, so on pressed, get the current Y, and then we're going to, for moving vertically with W, we're going to take the array location, and we're going to go minus, we're going to subtract, and we're going to subtract 1 from that location, and that will give us our next step location, basically. And so we're going to minus 1, and then we're going to get, we're going to copy and paste this, or just duplicate it. We're going to grab this again. We're going to get this location. This is going to be the new Y that we're moving to. And this is going to check if we can move to that location. And so we're just going to do a branch. And in checking if we can move to that location, it's going to set the can move boolean from our function here. So we set the can move boolean here. And so we'll use this as our condition. And on true, we might have to change this later, so we'll duplicate teleport. And on true, we will go to here, and our new location will be the new X and Y location from here, as long as we're allowed to move. So that should be all right. And then we're going to set our array location here to be this new location. We can just make a little thing, a little node. We'll clean that up a little bit. And this will be the tile index for the next location. And we're going to do the same, well, we'll do the same but opposite with S. So we're just going to delete this, control duplicate, bring it down here to S, we'll plug this in. Instead of subtracting 1, we'll subtract -1. And that will give us our new location. And that should all be in order, I believe. Alright, so now this will be pretty much the same, just a little bit more complicated than the other two to move sideways, because on the tile map it goes, the index is added like this, and so it goes up and down, so it's easier to go subtract 1, -1 versus the other way around. So we're going to duplicate this again, control duplicate, and this time around we're going to, instead of adding the instead of adding just one, we're going to have to add a whole row size of tiles. So our row size is 19, That should be our number that we have to do. So we'll go A would be minus 19 and control duplicate this again. This one will be, well, actually, sorry, it's already minus, so just 19. And this one will be plus 19. Or, so minus 19. We'll go into pressed again. And then we need to set the world rotation of our sprite. For both of these. So we'll control duplicate. Create the target. And we will go into the new rotation, which should be, I believe this one should be 90, 0, 0. And this will just make sure that when we go back this way, that our rotation goes back to what it originally was. And this one should be 90, 180, 0. And we'll check this out to see how this works. So right now we are off the map. What happened is we need to go back to here and instead of this node right here, or subtract 1 from this index here, we can use the original index. Like fix it. Let's see what happens. Let's try connecting the false here, just so we can make sure our movement works properly. And we can go back and fix that in a second. So we're one index too long or short. So first off, we're going to delete that. Back to our 2D character. And we'll change this to, let's go 20. 20. I'll save. I'm going right, and it's going one index up. Try 21, and then we'll go down to 18. See if that fixes it. So we'll go left, it goes one index to the left. Let's select let's try that one more time. Alright, so what's happening is our rotation is making it look weird. We can check the world location out here. So this is going around the Y, so we want to go back 180 around the Y. So when I go, maybe this should be 0 and the next one should be 180. Set this to 0, set this to 0. We'll go back through here and check this out. just to see what's going on. So we'll go set this to 90. Let's keep our rotations the same. Looks like the rotation around the Z just needs to be turned 180. Just do this to make sure that no matter what we press, that we get the same result. Alright, so that's fine. And we'll just go, one of these is going to have to be, we want this on the A key to be, that'll be fine. But on the other key, let's go negative 180, or so the D key is okay. So that's alright for the A key. Alright, now the D key just needs to be flipped. Try 0. So A key is still fine. Go back to we'll rotate around the Y. Keep this at 180. I should 180. Alright, so that works. Good movement, up, down. Alright, so now we're getting stuck in this spot. So we're going from bottom to top, which is good, but we can also cancel that out, just so it doesn't let us move. So basically what we're doing is we're dropping to the last index and then going to the next index in the next row. Which is what we don't want to happen, so that's where our function comes in here. So let's check this. Let's see, is valid index. That's something that we need to see. So true goes to here. And we're less than this. If we're less than 17, then we want to check one more thing to find if the tile is full. So if it's not found, the tile isn't full. So, and then that's true. And then we can, or if it is found, we want to set can move to 0. If it's more than this, we want to set can move to 0. And then if it's not a valid index, we want to set can move to not. So everything looks alright. So valid index true. And then if it's less than 17, which is our step size, should set to true. And then we want to say false if we did not find the index. Maybe these are switched around. So if we did not find the index, so -1 if not found, and the tile full set, we can move. So if this is true, not found, true, we can move. And that should be the return. All right, so let's try this again. So we have a better system for grid movement to an extent, but we do have this dead tile up here. So we need to fix that. We also need to make sure the collisions are working, so we need to go back to our 2D character. We need to go back to the event graph. And we only move if true. So that's fixed. Let's see. All right, so our tiles are not being added to the array, but we do have the dead zone along the edge of the map, which is a good thing. We can't move off the map anymore. So save that and then look back at our tile map. See what are we adding to tiles full? So we get the tile center positions, we add those to step positions, which is fine. Then we take the indexes from this and we add them to the for loop. Take the index here, we set the tile if this is true. And if this is true, then we add this tile to the get the tile center position. We find in the step positions and we add it to the tile full thing. And we should be printing the tile full length. All right, let's check our program again. So there's 2 tiles full, I believe. So let's, what else are we printing? Not sure what else we're printing. The text color, we'll put it in red so that we know that this is the one that we're looking at. 41 and then 0. Tile map editable. Oh, so we're setting the tile in different layers, I guess. We'll get the tile. It shouldn't matter. Space here too. So this chest is now not movable. All right, so that finally worked out. So that's how we're going to fake our collisions. You can fix this little thing right here. You can delete one row from your array. We can stop with the -1, I guess, maybe on this project. I made a different um, I made a different project where I used a similar system, and I had to subtract one. Um, so I'm not sure why that was the case, but I also didn't have the little rotation issue with the map sometimes on my other projects. So if you have any questions, just leave them below, or if you want me to expand on anything or to add anything to this. Um, I'm not sure if I'll continue making videos unless people uh, are making videos on this topic specifically. If people um, don't really care to hear about it, so I just thought there was a few things that no one else was talking about, just because a lot of people don't use this engine for this type of game, just because it's a little bit inefficient. But if you're a little bit more comfortable with the Unreal type game creating, this might be useful to you in some regard, because there's not really a good way to make a grid system with collisions unless you fake them. Um, there are some other ways, but it might be a little more complicated than this. Um, but yeah, I hope you found some of this helpful, and just let me know what you think or any other questions down below.